Have you ever stopped to really look at the world around you? I mean, really look. That device you're holding, the car parked outside, maybe even the building you're in right now, they all share this amazing secret. Almost all of them started out as just a boring, flat sheet of metal. So today, we're going to pull back the curtain on the hidden art and science of how we bend that metal into everything we use.
Right? It's a huge leap to go from a simple, flat sheet of steel or aluminum to something complex, like a car door or the casing on your laptop. How in the world do you get all those perfect shapes, those strong corners, and those sleek curves? Well, the answer is a fascinating mix of, brute force and some really elegant precision. Let's dive in.
Okay, so let's start at square one, the basics. Bending metal sounds, well, simple, doesn't it? You just bend it. But as you can probably guess, behind that seemingly simple action, there's a whole world of engineering and really precise science at play.
At its heart, the idea is something we've all done. Seriously, it's just like folding a paper airplane. The only tiny difference, your paper is a sheet of thick, tough steel. And instead of your hands, you're using machines that can literally exert tons of force. So, a little different. So here's the official, kind of nerdy engineering definition for it. And the key phrase here is plastically deformed. Now that's just a fancy way of saying it's bent, and it's going to stay bent. It's not like a rubber band that snaps back into shape. Nope, this change is permanent. So how does it actually happen? Well, you can think of it like a little three-step dance. First, you place the sheet of metal over a tool, usually V-shaped, that's called a die. Then, another tool, called a punch, comes crashing down from above, applying a massive amount of force. And that's it. The force deforms the sheet, giving it that new, permanent bend. So remember that trio, punch, sheet, and die. That's the core of it all. But of course, in the world of manufacturing, one size never fits all. It's all about precision, right? And that means engineers need different methods for different jobs. So let's look at the main ways they get that absolutely perfect bend.
I mean, think about it. How do you get that super crisp 90-degree angle you need for a computer case versus the really gentle, sweeping curve of a car's fender? Getting it right every single time means you've got to pick the right technique for the job.
So for making angles, there are two main schools of thought. First up is something called air bending. In this case, the punch only pushes the sheet partway into the die, so the metal is only ever touched at 3 points. It's super fast and it's really flexible. But then there's the second method, bottoming. And this one is all about pure power. The punch drives that sheet all the way down, stamping it into the exact shape of the die.
And this right here, this is a classic engineering trade-off. You can think of it like this. Air bending is your versatile Swiss Army knife. It's great for a ton of different jobs, and it does them quickly. But if what you need is absolute, repeatable, perfect every-time precision, well, then you need a scalpel. And that's bottoming. It really is all about choosing the right tool. Okay, great. So we've pretty much mastered the angle. But wait a minute. A lot of the metal things around us aren't really angular at all, are they? They're curved. And for that, you need a completely different approach.
And that different approach is called roll bending. Yeah, for this one, you can just forget everything about the punch and the die. Instead, the metal sheet gets fed through a series of incredibly powerful rollers. And by just adjusting the distance between these rollers, operators can create pretty much anything, from a gentle arc all the way to a perfect cylinder.
So we've got our ways to make sharp angles and our ways to make smooth curves. Now let's tie this all back to where we started. Why is this whole process, this fundamental action, just so important?
Well, here's the cool part. Because once you know what you're looking for, you start seeing it absolutely everywhere. The body panels on your car? That's bent metal. The huge steel beams in a skyscraper? Bent metal. The air ducts in your office? The little brackets holding up your shelves? The case protecting your computer? You get the idea. It is all a product of metal bending.
It's really one of those amazing foundational technologies that just quietly shapes our entire world. From the largest structures you can imagine to the tiniest little components inside your phone, we are literally building our modern lives one carefully calculated bend at a time.
It really makes you wonder, doesn't it? What other simple processes like this are out there, just hiding in plain sight, quietly shaping everything around us, just waiting for us to take a closer look? It's something to think about.